I'm going to talk about voltage in an RC circuit. These are circuits with a resistor, a capacitor, and a battery that are commonly used in electronics. Voltage is the measure of electric potential energy in a circuit, and batteries can provide this energy. In a circuit diagram, a battery is drawn like this, with the larger line representing positive voltage with a plus sign, and the smaller line representing negative voltage with a minus sign. The V next to an element in a circuit diagram signifies the magnitude of the voltage change across that element. It can be either a voltage gain, as in a battery, or a voltage drop, as you find across a resistor or a capacitor. The voltage drop across a resistor is proportional to the current, and written as V equals IR. Current is the rate of change of charge with respect to time, shown as I equals dq dt. A capacitor is made of two plates, one positively charged and one negatively charged, with an insulator in between. Capacitors have a voltage drop, which is proportional to the charge, and written as V equals Q over C, where C is the capacitance of the capacitor. When capacitors are fully charged, they let no current through. Now we will look at the equations that describe the circuit. I will start with Kirchhoff's voltage law, which states that the total voltage drop across a circuit must sum to zero. This is true due to the conservation of energy. The voltage change of the battery has an opposite sign than the voltage change of the resistor and capacitor because it's a voltage gain, not a voltage drop. And using these equations from earlier, we can substitute them into Kirchhoff's voltage law to give us negative V sub B plus dq dt times R plus Q over C equals 0. This is the differential equation that describes an RC circuit. By rearranging this equation and integrating both sides from time 0 to time t, we can get the solution for the charge on the capacitor as a function of time. Using the voltage drop across the capacitor equals the charge over the capacitance, we can rearrange this equation to get the voltage drop across the capacitor as a function of time. And then substituting this back into Kirchhoff's voltage law, we can get the voltage drop across the resistor. The plots of these functions look like this. The battery turns on at time t equals 0. In the limit, as time approaches infinity, the voltage in the capacitor approaches VB, and the time constant for this change is R times C, which means that the capacitor will be 63% charged in R times C seconds. As the voltage drop across the capacitor increases, the voltage drop across the resistor decreases, such that the sum of the voltage drop across the resistor and capacitor equals the voltage provided by the battery. Let's try to visualize this using an analogy to circuits, which uses water instead of charge. Here is our hydraulic circuit, which is a model of this RC circuit. In the hydraulic circuit, the pump is the battery, the gravel in the tube is the resistor, and the orange funnel is the capacitor. The water in the tube represents the charge, and the gravitational potential energy of the water represents the voltage. The pump does work to provide gravitational potential energy to make the water flow through the hydraulic system, just like the battery does work to make the charge flow through an electric circuit. As the water flows, it encounters resistance when traveling through the gravel in the tube, and the gravitational potential energy is decreased. This is shown by the water flowing to a lower height. This is analogous to a voltage drop in a resistor. The voltage drop across the capacitor in an RC circuit starts at 0 because there hasn't been time for the charge to accumulate. As the water begins to flow, you will see me increase the height of the funnel until it is equal to the highest point in the circuit. This is analogous to the capacitor being fully charged. Alright, let's see this hydraulic circuit in action. So the water flows and encounters resistance in the gravel tubing, and the capacitor lets water through until it reaches the highest gravitational potential energy state, and then water ceases to flow through the circuit. I hope this helps you understand these common circuits, and thank you for watching.